Welcome, folks. Our focus for today will be on a collection of gases. Now, collection of gases, we are looking at methods that we can use to collect a gas after being prepared. And these methods are considered to be whenever you prepare a gas under laboratory preparation. So here, the first two factors that you need to put into consideration whenever you are trying to choose a method to use whenever you want to collect gases. The first one, density. So the density has to be the comparison between the density of the gas you are collecting and that of air. So let's look at the density in terms of molar mass. So we are going to look at an estimated molar mass of air. So this one has about 28.9 grams per mole. Any gas with the molar mass less than 28.9 is considered to be less denser. So if we have molar mass less than 28.9, then we are dealing with a gas less than air. Then the reverse is also true. So 28.9, then we are dealing with excuse me, a more denser. So this is the point that we are looking at. For example, we can begin by finding the molar mass for the atomic hydrogen. So we know it's the hydrogen multiplied by 2, which is 1 times 2, giving us 2 grams per mole. So 2 grams per mole is less than 28.9. So this is a less denser gas. So let's say we move on to ammonia. So it's nitrogen multiplied by 3 plus hydrogen times 3, which is we have, this should be 1. So 14 plus 3 giving us 17. So ammonia is also less than is less denser than air. Then what else? Let's say we look at oxygen, the atomic. So it's 16 multiplied by 2, giving us 32. So oxygen is slightly denser than air. What of CO2, carbon dioxide? So carbon is 12, 32 for the atoms of oxygen, giving us 44. So this is more denser than air. Then what of Cl2, chlorine? This one will give us 35.5 times 2, giving us 71. So to summarize our work here, we are saying whenever you are trying to identify the gas, the density of the gas, whether if you want to know whether the density of that gas is greater or less than the density of air, the first one that we can just put it into consideration is the molar mass. So calculate the molar mass for that gas, then compare to 28.9, which is the estimated molar mass of air. Then from there we'll be able to see the gas that is more or less denser. Then number 2 factor that we look at is solubility. So solubility is all about if the gas is soluble or insoluble in water. So after we are done identifying these 2 factors, now let's look at the first method. So the first method that we are going to look at is downward delivery of gas. So for this one, you'll be able to see this by this diagram. So whenever you see this diagram, it's an indication of this method. So as you can see, the tube, this is the inlet, but the outlet is pointing down. So the gas, whatever gas that you are looking at is going down. Now, if you have just looked at these principles, the gas that goes down simply means that gas is denser than air. So for example, the gases that we can obtain in this way is chlorine. Remember, chlorine gave us 71, which is greater than that one. Then the other one is hydrogen chloride. Also this one can be used by this method. And carbon dioxide can also be done because carbon dioxide is also denser than air. Then this method is sometimes known as upward displacement of air. So I want you to see the difference. If you use the language downward, has to be delivery of the gas. The gas is delivered downward. The gas will go down because of the density. But upward displacement of air means that as the gas is going downward, then the air that was here will be displaced, will move up. Then the gas, since it's more denser, will settle down here. So that's the concept that we are looking at here. Then the second method is we are going to look at upward delivery of gas. So for this one, we have this. Then we have the inlet of the gas here. Now for this one, you can see that the gas is moving up, and for gas to move up, then the gas must have a density lower than that of air. So that's a key point here. So a light gas will go up, a denser gas will go down. That's a concept. Then the gases that we can expect to have here is ammonia, which is NH3, if you remember. Then also hydrogen can also be collected by this. Now, for gases that can be collected by the first method and this method, apart from being less denser than air, they have to be soluble in water. We can't use we can't use water to collect a gas that is soluble because it is going to dissolve in water. Then the other name for this one will be downward displacement of air. Why do we say downward? This time, since the gas is going up, then the air molecules will move down since they are denser than the gas that we are solving at here. So that's a concept that we have here. Then the last method is about collection, where we use the displacement of water. So we'll begin with drawing this illustration. I'm sure as you have been revising, you have, I'm sure, once come across a diagram like this. So this is also another method that you can use to collect a gas. Now for this method, the density of air is not put into consideration. So irrespective of the density of air, any gas can be collected by this method. So the condition is the gas must always be insoluble, because if we use a soluble gas, then it's not going to pass through water. So we need a gas that will pass through, then it displaced by water until the gas is collected at this. And the best way to know that the gas is now collected, then we will see that these water molecules will move down, leaving enough space for the gas to be collected. So for this method, I'm saying it can be used to collect any gas irrespective of the density, because water is denser than any gas here. Now, for example of gases that can be used, we can look at carbon dioxide, because this one is, though it is slightly soluble in water, but it can be collected by this method. Then hydrogen can also be collected because of being insoluble. Then oxygen can also be collected. So to summarize our work is, we are saying the collection of a gas depends on solubility and the density of air. The first two methods are used to collect gases depends on the density, and the gases that can be used, that can be collected by the two methods that we looked at earlier, are those that are soluble in water. Then for this one, we are saying for this one, it can be used to collect any gas as long as the gas is insoluble in water. Now, how can we put this information to good use? So we are going to look at exam questions where we can apply these. Okay, so we have this question as our first example. The diagram below shows the setup of the apparatus that will be used to prepare gas X. Now the reactant is hydrogen peroxide. So this is working as our reactant. Then after decomposition of this hydrogen peroxide, we have this gas X produced, and we can see the method that was used here. I'm sure you are able to remember. So the method that was used here depends on the properties of the gas. Now let's now answer our question A1, identify gas X. So gas X is oxygen. Why do we say oxygen? Because oxygen can be prepared by using the decomposition of hydrogen peroxide. So whenever you see hydrogen peroxide in the presence of manganese 4 oxide, then the gas produces oxygen. Now move on to Roman number 2. Describe the chemical identities for gas X. So how can you know the gas produces oxygen? So we'll say it relights a glowing splint. So it relights a glowing splint. Right, then B1, what is the purpose of adding manganese 4 oxide to hydrogen peroxide? So say to speed up the rate of reaction. So to summarize, it is just acting as a catalyst. Now we have question Roman number 2. Explain why this gas is obtained using the method shown in the diagram. So now we can now apply. So number 1, since we have water here, so the first one, the gas is insoluble in water. So that's the reason that we are going to use here. So because oxygen is insoluble in water. Okay, so move on to question 2. The diagram below illustrates the laboratory preparation of ammonia. Right, so now construct a balanced chemical equation for the reaction being illustrated in the diagram above. So let's look at the reactant. So we have ammonium chloride, then we'll also have calcium hydroxide as a base. So our chemical equation is this one. So ammonium chloride has this chemical formula plus calcium hydroxide. Now for the products, so you can just commit this part to memory. So here we are going to have ammonia NH3. So this is the gas that we want to prepare. Then what else? So we are going also to have water vapor plus calcium chloride. So this is what we are expected to have. Now our work is we need to balance our chemical equation. So we can put 2 here. so that 2 nitrogen, 2 nitrogen. Then for hydrogen, we have 4 from ammonium chloride and 2 from calcium hydroxide, making it 6. Then here we have, also we can see that we have 80, so we have 6 from here, then plus 2, 8. Then 1 atom. What else are we supposed to do here? We can put the 2 in front of water. Then what else? So our equation is now balanced. So the key point is, whenever you are taught to look at the question of preparation of ammonia in the laboratory, it is the decomposition of ammonium chloride in the presence of calcium hydroxide. Then we go to B1, state the common name of substance X. So this substance X has a role that it plays during the preparation of this ammonia gas. Now the common name is, so first let's give the chemical name, which is calcium oxide. So calcium oxide has the common name of quicklime. Then what is the purpose of substance X? So remember, our aim is to produce ammonia. Now the ammonia, as the ammonia is passing through this, may contain some water molecules. So in order to get rid of the water molecules, or to make the gas dry, is now this Xe comes in. So we'll say to dry out the ammonia. So to summarize our work, we are saying this calcium oxide or quicklime is just working as a drying agent. We move on to question C. Why is ammonia collected by using the method shown above, not above water? So the reason why we can't use that where we have water, so say because ammonia is soluble in water. So if we use water, the ammonia will not pass through water, it will now dissolve. So that is what we are looking at here. Then for D, describe the chemical test for ammonia gas. So we say it turns damp litmus paper blue. Then he states 2 uses of ammonia. The first one, say to make fertilizers, then also to make explosives, because this gas is poisonous. Okay, so now we can have our last example for this video. So 3 gases A, B, and C have properties shown in the table. So gas A, more denser than air, soluble in water, colorless. Then B will have less denser than air, soluble, colorless. C, more denser than air, insoluble, colorless. So from the properties that we looked at, I'm sure you can have the picture of what we are looking at. So this method here, we said, is known as a downward. So downward, the delivery of gas. Then we have upward delivery of gas. Then this one is displacement of water. Now we can now summarize it. So the one that we can use for the first one, for this one is the first one, more denser than air, then less denser than air. So it has to be soluble and also here soluble. For this one, we are not interested in density. Our focus is the gas must be insoluble. Now let's look at the first question. So the first question is, which apparatus X, Y, or Z is most suitable to collect? The first one, gas A. So let's look at gas A. Gas A more denser than air, then soluble. So we need to use the downward, which is X. What of B? Let's look at the characteristic of B. Less denser than air, soluble, so we need to use Y. Okay, so let's check for question B. Gas C can be collected using apparatus Z. So apparatus Z, we say it is the displacement of water. So state why apparatus Z is more suitable than apparatus Y to collect gas C. So the reason why we cannot use the apparatus Y, there are two reasons here. Apparatus Y, we are looking at the upward. Then for gas to use this one, the most important property is must be less denser, because if it's less denser, it is able to go up. Now if you look at gas C, is more denser, so this cannot go up because of the density. So say because gas C is more denser, and insoluble in water. Then Roman number 2, state why apparatus Y is more suitable than apparatus Z to collect gas B. What did we say about gas B? So gas B, less denser than air, soluble. So less denser than air, soluble. Less denser than air, soluble. So state why apparatus Y is more suitable than, so say because gas B is less denser. Is less denser than air and soluble in water. Right, what else? We have the last question. Suggest a name of gas that would be collected using apparatus X. So apparatus X is a downward delivery. So downward delivery, we can use any gas that is soluble and denser than air. So for this one, we can use chlorine. We can also use hydrogen, chloride, even carbon dioxide. So this is how we can apply what we learned. So that's it for this video. Thanks for watching.